Welcome to the question you've always wondered about. Somewhere in the vast silence of the universe, a question echoes endlessly. Are we truly alone? In a cosmos containing hundreds of billions of galaxies, each with hundreds of billions of stars, is it possible that Earth is the only place where life ever emerged? Or have we simply not been listening closely enough? Tonight, we are not in a hurry. We are not trying to arrive anywhere. We are here simply to think, simply to listen, simply to be. When we look up at the sky, most of the time we see only darkness. But this darkness is not emptiness. On the contrary, it is a fullness so deep and ancient that the human mind struggles to comprehend it. It holds the weight of billions of years, the birth and death of stars, the silent dance of galaxies spinning far beyond our reach. And within this fullness, an unsettling yet fascinating question waits silently. In such a vast universe, where is everyone? This question is not new. For decades, it has wandered through the minds of astronomers, philosophers, and people who dare to dream. It has echoed in the quiet of observatories, in the pages of books, in whispered conversations under starlit skies. There are countless stars, there are countless planets, and time, almost endlessly long, stretching beyond imagination. Yet despite all this, the universe seems to tell us nothing. No message, no sign, not even a distant whisper, as if the universe were in a deep sleep. When you lift your head toward the sky on a clear night, you see a few thousand stars scattered across the darkness, like tiny grains of light sprinkled over black velvet fabric. And yet, even this is only a hint, a mere glimpse of the vastness that lies beyond. What we see is almost nothing compared to what is actually there. The observable universe stretches approximately 93 billion light-years from end to end. You do not need to imagine it. Simply accepting it is enough. In this universe, there are at least 2 trillion galaxies, each one like a massive city of stars, slowly rotating within the dark. Its billions of suns casting light that may never reach anyone. And our home, the Milky Way, is only as small as a grain of sand on this immense scale. Within the Milky Way, there are hundreds of billions of stars, each one potentially hosting planets, moons, and possibilities we have yet to imagine. If you counted just 1 star per second, without sleeping, without stopping, without even blinking, it would take thousands of years just to count the stars in our galaxy alone. This span is longer than the entirety of human history, longer than all the civilizations that have ever existed, longer than the time it takes for continents to drift or mountains to rise. And this is only one galaxy, just one neighborhood in a cosmos so vast that our minds can barely hold the thought. For a long time, we thought we were alone. We believed our solar system was a rare exception, a fragile miracle in the immense night. But now we know that planets are everywhere. Around nearly every star, worlds revolve in silence. Some are giants made of gas, enormous and tempestuous. Others are rocky, harsh, familiar, perhaps real enough to stand upon. Some of these planets exist within that delicate zone, neither too hot nor too cold. That narrow range where water can remain liquid, where life in some form might be possible. In our galaxy alone, there may be tens of thousands of potentially habitable worlds, each one silent, each one dark, each one unknown. Perhaps some planets have oceans. Oceans no ship has ever sailed, no eye has ever seen. Perhaps the winds are singing songs we will never hear. Perhaps mountains rise where no foot has ever trod. And perhaps there, somewhere, someone is looking up at the sky, wondering, just as we do, whether they are truly alone. The mathematics is simple. The probabilities are enormous. If life emerged on only a small fraction of these worlds, if an even smaller fraction became intelligent, then the universe should be full. But it is not. At least, it does not seem so. Radio telescopes listen. Telescopes observe. Years pass. Generations of humans gaze into the night, and the only thing heard is silence. No messages, no visitors, no distant signal. The universe stands like a giant house with its lights turned off. Its vast halls echo with possibilities that may never awaken. The universe has existed for approximately 14 billion years. We, by comparison, are very new. This means there has been plenty of time for others. Time to spread, time to communicate, time to leave a mark. Yet there are no traces, no whispers, no signs of anyone else reaching out. And so the question remains, unanswered, silent, neither frightening nor comforting. It simply exists, hovering in the vastness, waiting for our reflection. Tonight, when you look up at the sky, perhaps you will feel the universe is a little bigger, a little lonelier, and a little more mysterious than yesterday. And perhaps that feeling is the quietest thought one can carry before falling asleep. A thought that lingers without movement, without noise, yet deeply present, reminding us of both our smallness and our wonder. The universe is vast, almost unimaginably vast, and within it, somehow, consciousness has arisen. Within it, somehow, we exist. But strangely, much of that vastness does not touch us. It flows beyond our reach. It spreads into distances we cannot traverse. Almost everything beyond our local cluster of galaxies is drifting away from us with the expansion of space itself. No matter how fast we imagine traveling, no matter what extraordinary ships we dream of, we will never truly reach them. The moment we think we are approaching, they have moved just a little farther, like a horizon that retreats as you walk. An endless, patient horizon. So let us narrow our gaze. Let us turn inward to a place more intimate, to our own home, the Milky Way. The Milky Way, with its arms stretching outward from a bright center, is a vast spiral galaxy. If you could see it from outside, it would appear frozen in time, like a suspended firework, or perhaps like a gentle whirlpool made entirely of light. From one end to the other, it spans roughly 100,000 light years. Even light takes 100,000 years to travel from one edge to the other. Our sun sits not too close and not too far from the galaxy's center, in a region astronomers affectionately call the galactic suburbs, not in the chaotic, dangerous crowd at the center, but also not in the lonely, empty outskirts. From a cosmic perspective, it is a relatively calm neighborhood for life. The Milky Way is not only vast in space, but also in time. Our galaxy is roughly 13 billion years old. Our solar system, by contrast, is only 4.5 billion. This means that even while the Earth was still a cloud of dust, opportunities for life had already existed elsewhere. To feel the passage of this time more vividly, let us imagine if we compressed the entire history of the galaxy into a single year. The Milky Way would form on January 1st. The Earth would appear only in the final days of September. Complex life would have to wait until mid-December, and we humans would not arrive until New Year's Eve, just minutes before midnight. All of human history would flash briefly as a tiny spark, shining and fading seconds before the new year began. The earliest days of the galaxy were far from calm. Supernova explosions bathed nearby systems in lethal radiation. Heavy elements required for life had not yet spread sufficiently. This era was not hospitable for something as delicate as life. But time passed. 1 or 2 billion years later, the galaxy became more stable. Heavy elements increased in abundance. Planets began to form, and the first truly habitable worlds emerged. Some systems began far, far earlier than ours. Long before our sun existed, long before our planets took shape. Imagine a planet that formed when the galaxy was only 3 billion years old. This world would have nearly 10 billion years of history, more than twice the age of our entire solar system. If life had ever emerged there even once, it would have had almost limitless time to evolve. Time for creatures to adapt, to diversify, to explore their worlds. Time for oceans to rise and fall. Time for continents to shift and climates to change. Time for unimaginable ecosystems to flourish. Time for entire civilizations to rise and fall. If intelligence had arisen there, and yet, despite this vast opportunity, we look out into the darkness and hear nothing, no signs, no stories told across the light years, only the quiet, patient emptiness of space. The universe's history is immense, almost impossible to grasp, and in this immense history, we are nothing more than a brief flicker, a spark that has just begun to shine. Yet this knowledge does not diminish our existence. Instead, it deepens the wonder, the awe, the fragile, precious miracle of life here on Earth. The universe is so vast, so full of opportunity, and yet so profoundly quiet. On Earth, complex life advanced from simple cells to humans in less than 4 billion years. 10 billion years could have made far more possible. Entirely different forms of intelligence, entirely different technologies, entirely different ways of understanding the universe. If such civilizations ever existed, they might be as distant from us as the first bacteria are from humanity. Perhaps they no longer need physical bodies. Perhaps they exist as information or as patterns of energy. Perhaps they manipulate matter and time in ways we cannot even begin to imagine. And when you think about it, if humanity truly wanted to, if it combined all its resources and determination, it could colonize the galaxy in roughly 2 million years. That may sound like a long time, but on a cosmic scale, it is barely a blink of an eye. And this is where the problem begins. If it was truly that feasible, if there was truly that much time, then why is there no trace? Why is the galaxy still so silent? These journeys would not be fast. No one would exceed the speed of light. Even the fastest spacecraft we have today would need tens of thousands of years to reach the nearest star. But if there is time, enough time, if there are resources, and resolve. Then such journeys become possible. Let us imagine for a moment a spacecraft the size of a small city, 50,000 people living inside, closed-loop life support systems, artificial gravity, a voyage lasting across generations. The ship departs, and the journey lasts perhaps 1,000 years. At the destination, a colony is established, infrastructure is built, new ships are constructed, and then, farther still, each colony becomes a starting point for the next journey. Not a single ship, not a single destination, but a branching process, like ripples spreading from a stone dropped into a pond, silent, slow, yet unstoppable. Journeys take centuries. Settlements take centuries as well. But with each new colony, the process accelerates. This is exponential growth on a galactic scale. Within roughly 2 million years, every star system in the galaxy could become reachable. 2 million years. In a history spanning 13 billion years, that is almost nothing. If intelligent life emerged even just 10 million years ago, there would have been time to colonize the entire galaxy many times over. If it emerged 100 million years ago, it could have happened dozens of times. This line of thought deepens the Fermi Paradox even further. The problem is not merely that we do not see aliens. The real problem is this: if they existed, they should have been here millions of years before we ever appeared. Perhaps they did come. Perhaps they visited Earth, studied early life, observed primitive biology, and then moved on. Perhaps the traces they left behind were erased by millions of years of geological change. Or perhaps they never came at all. Perhaps interstellar travel is far more difficult than we imagine. The distances are immense. The dangers are countless. The energy demands are overwhelming. Perhaps most civilizations look up at the sky and decide not to go. They build rich, complete lives around their own stars. They turn inward rather than outward. They explore depth instead of distance. They find meaning without expansion. And it is at this point that we realize something important. To bring all these possibilities together, we need a framework, a way to understand why the universe is so vast, so full of opportunity, and yet so profoundly quiet. Not a framework that organizes numbers, but one that organizes questions. In 1961, an astronomer named Frank Drake did exactly that. The Drake equation was not designed to produce an answer, but to help us think, a way to organize our ignorance, a way to place our uncertainty into structure. The equation itself is simple. It multiplies a series of probabilities. Each term represents an obstacle standing in the way of life, a filter, a gate that must be passed. In our galaxy, there are approximately 20 billion sun-like stars. Roughly 1/5 of them have Earth-sized planets within the habitable zone. That means around 4 billion potentially habitable worlds, 4 billion stages, 4 billion chances. But now we arrive at the difficult part. On how many of these worlds does life actually begin? We do not know. Let us assume only 1%. Even then, that would mean 40 million living worlds. But life alone is not enough. Intelligent life is required, and technology. With each step, the number shrinks further. Simple life may be common, but complex consciousness and technology that does not destroy itself, that may be exceedingly rare. And then comes the final filter, the most ruthless one. For how long does a civilization remain detectable? They may survive for millions of years, but the time during which they make noise, broadcast signals, or leave visible traces may be very short. When all these factors are multiplied together, the result can be anything from 0 to thousands to billions. The beauty of the Drake equation lies in the fact that it does not give an answer. It holds up a mirror. It reflects both our hopes and our limits. 31. The final quiet thought. The numbers whisper that we should not be alone, but observation is silent. And in the gap between these two, one of the deepest mysteries of our time waits. Perhaps life is far more fragile than we imagine. Perhaps we are a rare moment that awakened at exactly the right time. Perhaps the reason for the universe's silence is not the difficulty of life beginning, but the difficulty of learning to unite. Simple life can exist alone. It can survive. It can adapt. But complex life requires cooperation, moving together, sacrifice, harmony. It is entirely possible that the galaxy is filled with countless planets, teeming with microbes, oceans full of bacteria, atmospheres carrying biological signatures, yet worlds that never go any further. Because that critical threshold, the threshold of cooperation, was never crossed. Even after complex cells emerge, the path is not easy. Multicellular life requires billions of cells to behave as a single organism. Cells must learn when to stop reproducing. They must abandon individual advantage. This is, evolutionarily, an extraordinarily fragile balance. Even today, what we call cancer is simply the collapse of that balance. A cell rejects cooperation. It multiplies only for itself. Perhaps on many planets, complex life never overcame this internal threat. And then, intelligence. Intelligence is not inevitable. On Earth, life existed for billions of years. Without intelligence, dinosaurs ruled for 160 million years. But they never built radio telescopes. Perhaps intelligence is not the natural outcome of evolution, but a rare side effect. And intelligence alone is still not enough. A species must be capable of moving beyond its instincts. A species must be willing to abandon short-term gains and choose long-term survival. This is rare behavior in nature. Technology grants power, but it also introduces risk. When a species learns to control energy, it simultaneously acquires the power to destroy itself. Nuclear fire, biological threats, systems that spiral beyond control. Perhaps this is the most common filter of all. Perhaps most civilizations lose themselves in their own trial. Before ever reaching the stars, they disrupt their climates. They exhaust their resources. They wage wars against one another. The silence is not an echo from afar, but the result of a sentence cut short. And perhaps some do pass this stage, but only for a brief moment. They send radio signals. They leave technological traces. Then, silence. On a galactic scale, the period during which a civilization is loud may be incredibly short. Perhaps the galaxy is filled with civilizations, passing one another unseen. Their timelines do not overlap. Their signals never coincide. The rise of one aligns with the long-extinguished end of another. And so, when we look up at the sky, we are not only seeing the universe, we are seeing ourselves. Silence may not be an answer. It may be a warning or an invitation. We do not yet know. Have we already passed the hardest barriers? Or is the most dangerous one still ahead of us? The answer to this question is bound to our future. Perhaps right now, we stand at the most fragile point in the life of a civilization, powerful enough, but not yet wise enough, fast enough, but not yet careful enough. If the universe is silent, perhaps the answer lies in what we choose to do, whether we choose cooperation, whether we think in the long term, whether we protect our own planet. Perhaps the galaxy is not empty. Perhaps the galaxy is filled with those who tried. And the silence is a gentle reminder of how many did not succeed. It is not difficult to imagine what this might look like. Perhaps one day, a civilization believes it has solved one of nature's deepest secrets. At first, this discovery feels like salvation, infinite energy, limitless power, every problem seemingly resolved. Everything appears to be under control. But at this precise moment, something subtle begins to unfold. Hidden within this knowledge is a cost. At first, it is invisible, silent, unhurried. The civilization continues living. Cities remain standing. Lights stay on. But as time passes, small imbalances begin to accumulate. Perhaps it is an intervention in space itself. Perhaps a minute disturbance in the natural flow of matter or energy. But nature does not forget such touches. And beyond a certain point, return becomes impossible. If such a threshold truly exists, then the silence of the galaxy is not a coincidence. This silence is a rule, a boundary beyond which voices cease and traces are erased. And perhaps this boundary inevitably stands before every technological civilization. This thought is unsettling because then, when we look into the emptiness of the sky, what we see is not an answer from the past, but a sign pointing toward the future, as if the universe is not shouting at us, but whispering a warning. Perhaps that is why no one answers. Perhaps those who survived are the ones who learned to remain silent, those who do not announce their existence, who leave no traces, who choose not to draw attention. Or perhaps no one survived at all. At this point, the question changes. We no longer ask, "Where are they?" Instead, we ask, "What happened?" And without realizing it, this question forces us to look at ourselves. Because we are walking the same path, we have not yet spread among the stars. We have not yet crossed the irreversible threshold. But with each passing day, we move a little closer to it. This transforms the Fermi Paradox from an abstract idea into something personal, into a question we may one day be forced to answer. If the galaxy is filled with stories that began with hope and ended in silence, then the stars are not just sources of light, they are also silent witnesses to the past. And perhaps the universe is not waiting for anything from us. Perhaps there is no test at all, but perhaps there is. Perhaps the real test is not how far we can go, but whether we know where we should stop. That deep silence we feel when we look up at the sky may be the only question. The universe is asking us, will you be different this time? And the answer has not yet been given. Perhaps everything begins with an energy source that appears clean and limitless at first glance, a power believed to cause no harm to nature, perhaps even to perfect its balance. But over time, it becomes clear that this energy creates subtle instabilities in the fabric of the universe itself. At first, no one notices because the consequences do not arrive immediately. Or perhaps the problem is not energy at all, but the way intelligence is used, systems designed to help, to solve problems, to optimize decisions. At first, they are tools. Then they become partners. And without anyone noticing, they turn into mechanisms that replace their creators. They may not destroy their makers, but they make them unnecessary. And a civilization, without realizing it, slowly erases its own role from the universe. Or perhaps disaster arrives through the dream of faster-than-light travel, a technology that functions flawlessly, calculated to perfection, until one day a small error turns into a cascading collapse. Explorers are lost, then the worlds that sent them, and what remains is nothing but cosmic emptiness. The most frightening part of this possibility is that no one would see it coming. The final words of every advanced civilization are likely the same. This new discovery will solve all our problems. And then only silence follows. In this case, knowledge is not salvation, but a minefield, and we are explorers moving forward without knowing which step will be our last. In such uncertainty, the most rational strategy may be to hide, to hold your breath, to hope no one notices you. When we apply this analogy to the cosmos, the picture becomes even more unsettling. The galaxy may be filled with intelligent civilizations that have learned that revealing one's existence is foolish. Every planet that sends radio signals, every world that broadcasts messages into space, is like someone lighting a fire. In the middle of a dark forest, it not only reveals their location, but also announces how inexperienced they are. Perhaps we are exactly that, naive creatures, shouting joyfully, unaware of the rules of the forest. This idea may also explain why we do not see massive engineering structures like Dyson spheres. Perhaps building anything too large, too visible, is an invitation to disaster. Perhaps successful civilizations are those that learn to develop quietly, those that manage to leave no detectable trace from afar. In this scenario, intelligent civilizations are the silent ones, an invisible community, scattered across the galaxy, perhaps sensing one another's existence, but never communicating directly. And this becomes even more meaningful when we consider the possibility of predatory civilizations. Perhaps the galaxy contains hunters, entities that eliminate less advanced species. Perhaps newly emerging intelligence is erased before it ever has the chance to grow. In this case, silence may be the most important message the universe is sending us. Those who survive are the ones who learn to remain hidden until they are strong enough, but perhaps Perhaps all of this is too dark. Perhaps the reason for the silence is not fear, but a form of existence so different that we cannot even imagine it. Perhaps the problem is not that the universe is empty. Perhaps it is that we do not truly understand what we mean by life or civilization. Let us imagine civilizations that can fully control their planet's atmosphere, that can detect and prevent asteroid impacts in advance, that have explored every corner of their worlds. Compared to such a scale, we humans are still at a very early stage. On the Kardashev scale, we are around level 0.7. We move slowly, but our direction is clear. Step by step, we are approaching the threshold where we can fully understand and control our planet. But the next level is not merely progress. It represents an unimaginable leap. A Type 2 civilization is one that no longer controls only its planet, but the entire energy output of its parent star. This is often associated with theoretical megastructures known as Dyson spheres or Dyson swarms. Such a structure would surround a star partially or completely, capturing every photon it emits and converting nearly all of it into usable energy. From a distance, such a system would not look natural. It might appear as a strangely dimming and brightening star, or as a celestial object emitting light at unusual wavelengths with an unexpected signature. Billions of individuals of such a civilization might live in enormous artificial habitats, each larger than a planet, silently orbiting their star. But the final step of the scale exists where science and speculation begin to blur, where reality feels almost like magic. A Type 3 civilization controls not just one star, but the energy of an entire galaxy. For such beings, stars are like pieces on a chessboard. Planets can be created, planets can be destroyed. Even the fundamental forces of nature can be directed as desired. At this point, physical bodies may no longer be necessary. Such beings may exist, partly or entirely, as information. They may live not in matter, but within patterns, within structure itself. Entities that think on the scale of galaxies, that act on galactic distances, almost like godlike presences. This scale casts the Fermi Paradox in a very different light. Perhaps we do not see advanced civilizations because we do not yet know where to look. Perhaps our galaxy is filled with Dyson-like structures we fail to recognize. Perhaps the strange behavior of certain stars is actually the side effect of a Type 2 civilization harvesting energy. And perhaps Type 3 civilizations are so advanced that their activities appear to us as nothing more than natural cosmic processes. But what if these classifications are missing the real point? Perhaps truly advanced civilizations do not focus on collecting ever more energy. Perhaps instead, they discover ways to achieve extraordinary efficiency with remarkably little energy. Perhaps rather than overpowering nature, they learn to work in harmony with it. They stop being engineers and become gardeners. Instead of forcefully reshaping their surroundings, They guide them gently. Such civilizations could exist everywhere, yet their methods may be so subtle that we fail to notice their touch. Perhaps what we call evolution is actually intelligence, guiding nature so skillfully that it becomes indistinguishable from it. Perhaps the elegant laws of physics that make life possible are not accidents at all, but the result of engineering on a scale beyond our comprehension. In that case, silence is not absence. It is our perceptual blindness. The universe may be speaking. We simply do not yet know its language. The Kardashev scale rests on a fundamental assumption about intelligence. It assumes that the ultimate goal of an advanced civilization is outward expansion to control ever greater amounts of energy and resources. This is understandable when viewed through the lens of human history. But what if this is not a universal rule, but merely a temporary phase, specific to our species? What if truly advanced civilizations follow an entirely different path? Perhaps the reason for the silence is that civilizations turn inward, not outward. Perhaps technology is not used to travel between stars, but to explore the endless landscapes of consciousness and experience. This can be thought of as the inner space hypothesis. According to this idea, once a civilization reaches a certain level, it may find the infinite depth of constructed inner worlds far more compelling and fulfilling than the finite expansion of the physical universe. Let us pause for a moment and consider, no matter how vast it is, the physical universe is bound by rules. There is a limit to the speed of light. Distances are enormous. Resources are finite. But within a constructed universe, none of these rules need apply. The laws of physics can be rewritten. The flow of time can be altered. Any imaginable world can be created. For a civilization with access to such capabilities, why would journeys that take thousands of years between stars remain appealing? For them, reality may no longer be an external discovery, but an internal creation. In this case, the galaxy could be full of civilizations, yet each one may live within the digital paradises it has created, largely indifferent to the outside world. They may not look toward the stars because they have created brighter stars within their own minds. This offers an exceptionally elegant solution to the Fermi Paradox. No catastrophe is required, no great barrier, no hostile intent, only a matter of priorities. The silence is not because the universe is empty, but because it is no longer the most interesting place to be. This may one day apply to us as well. As immersive virtual realities advance, inner worlds may become more attractive than the outer one. This inward evolution also explains why civilizations might leave behind such faint energy signatures. Instead of controlling galaxies, their goal may be to create the richest possible conscious experience, using the least amount of energy. This would render them almost invisible to us. Instead of Dyson spheres, they might exist as extraordinarily efficient systems, quietly operating on a single planet. This is both a fascinating and unsettling possibility. Even if we were to encounter them, would we be able to understand one another? Perhaps intelligence, given enough time, evolves beyond anything we currently mean by consciousness. Silence may not signify the absence of intelligence. It may instead signal the presence of a form of intelligence too advanced for us to perceive. And yet, the imagination of the universe is far broader than our own. Perhaps some civilizations evolved along paths entirely unlike the carbon-based life we are familiar with. They may be based on silicon chemistry, their thoughts forming slowly, like geological processes that unfold over millions of years. For them, time flows far more patiently and deliberately than our hurried perception allows. Perhaps some forms of intelligence exist as pure information, emerging within complex patterns of electromagnetic fields, or within quantum fluctuations themselves. They possess no bodies and are bound to no planet. For them, thinking may not be an action, but a vibration. How could such an intelligence ever communicate with us? Perhaps consciousness does not arise only in brains as we know them. It may emerge within the plasma flows of a star, within the intricate gas motions of a nebula, or even within the very fabric of space-time itself. The universe may be filled with countless overlapping layers of awareness, stretching from the quantum scale to the cosmic scale, and we may perceive only a narrow band of this reality, a thin slice of time and space, tuned to our own limitations. In this case, the universe is not silent at all. On the contrary, it may be filled with a vast ocean of consciousness, constantly speaking, constantly resonating. We are simply listeners who can hear only our own frequency, deaf to everything else. We might compare this to our relationship with an ant colony. Ants build complex societies. They communicate, labor, adapt, and survive. Meanwhile, we construct cities beside them, communicate wirelessly across the planet, and observe events unfolding on the other side of the world in real time. Our radio waves pass silently through their reality. The ants neither understand nor even perceive our presence. To them, we are nothing more than an incomprehensible, slowly moving force of nature. Perhaps we are the ants of the universe. This thought is both mesmerizing and unsettling, because if this is true, even if we were to encounter such beings, the gap between us might be so vast that meaningful communication would be impossible. They might remain completely indifferent to us, or pass over us without even noticing. But perhaps with great power comes great wisdom. Perhaps their deep understanding of the universe has taught them to recognize the value of even the simplest and youngest forms of life. In that case, silence would not be indifference, but deliberate protection. This leads us to the zoo hypothesis. Have you ever felt watched, even when you were alone in a room? That subtle unease, that faint, unexplainable chill. Perhaps, when considered on a cosmic scale, this sensation is not entirely meaningless. According to the zoo hypothesis, advanced civilizations do exist, but they choose to hide themselves to avoid interfering with the natural development of young species like ours. In this scenario, we exist within a protected region of the cosmos. We are observed, but not intervened upon. Consider wildlife research on Earth. Scientists studying animals in their natural habitats strive to remain invisible because their presence alters behavior. perhaps advanced civilizations, have adopted the same ethical principle on a galactic scale. Perhaps they understand that young civilizations must be allowed to make mistakes, to learn, and to find their own paths. Perhaps they have learned again and again that early contact, even when well-intentioned, causes more harm than good. In this case, the silence of the galaxy does not signify abandonment, but intentional distance. This idea is unsettling, yet strangely hopeful, because it suggests we are not alone, but we are being left alone, and that may not be a loss, but an opportunity. Perhaps at this very moment, observers that have existed for billions of years are watching us, silently following the birth of our sun, the first emergence of life on Earth, and now our hesitant first steps into space. If so, the true question becomes this: when does the observation end? At what point do the gates of the cosmic zoo open? Perhaps the threshold is not purely technological. Perhaps the true test lies in how we use power once we attain it, whether we can learn to live together without destroying ourselves, without exhausting our planet. Perhaps the silence of the universe is not a judgment, but a waiting, a patient, careful, and very long waiting. And perhaps the answer does not lie among the stars, but in the kind of civilization we choose to become. This is not merely a technical achievement. It is also a sign of maturity, an indication that we understand or can control the fundamental forces of the universe. To join a galactic community, it may be necessary to be capable of traveling at least within your own neighborhood. In this scenario, the silence is a natural consequence of our technological childhood. However, the threshold may involve far more than technology alone. Perhaps there is a social or political threshold. Perhaps the observers are waiting for us to overcome problems such as war, inequality, poverty, or planetary-scale environmental destruction. How wise would it be to open the gates of the galaxy to a species that cannot live in peace with itself, that cannot protect its own home? It would be like handing a child the keys to the entire house before they have learned to clean their own room. Perhaps the universe has a natural mechanism that prevents civilizations unable to resolve their internal conflicts from carrying those conflicts to the stars. Silence, then, is a sign that we have not yet passed this test of social evolution. At an even deeper level, the threshold may be philosophical. Perhaps it requires reaching a certain wisdom, a certain understanding of our place in the universe. We may need to overcome our cognitive biases, transcend tribalism, and learn to see ourselves not merely as members of a nation or even a species, but as potential citizens of a cosmic community. It is the moment when we stop asking only whether someone is out there and begin asking how we could form a meaningful relationship with them if they exist. It is realizing that the universe is not just a reservoir of resources, but a living whole that deserves respect. The convergence of these different thresholds helps explain why contact may be so difficult and so rare. Perhaps a species must pass all of these tests at once. It must be technologically advanced, socially stable, and philosophically mature. This is an extraordinarily high standard, and perhaps very few civilizations ever reach it. The true value of the zoo hypothesis lies not so much in whether it is correct, but in how it forces us to reflect on our own civilization. If we are being observed, What kind of example are we setting? If there is a test we must pass, how should we prepare for it? If there is a threshold we must reach, what steps must we take to get there? Perhaps every step we take toward solving the Fermi Paradox is actually a step toward that threshold. Our scientific curiosity, our philosophical questioning, our efforts to build a more just and sustainable world. All of these matter not only for our own future, but also for our potential place in a cosmic future. This silence may not be an ending, but a beginning, a period granted to us to prove that we are ready to cross the threshold and join the conversation. Sometimes the deepest answers are the simplest ones. Perhaps the reason we see no evidence of life across the galaxy is not because it is hidden or destroyed, but because it truly is extraordinarily rare. Perhaps Earth is not a typical planet, but an exception. We may be the winners of a cosmic lottery, in which the odds of life are far lower than we assume. This idea is known as the rare Earth hypothesis, which suggests that complex life, especially intelligent life, requires such a delicate combination of conditions that it becomes essentially unique. Perhaps we are not just lucky to be here. Perhaps we are impossibly, unimaginably fortunate. This hypothesis argues that finding a habitable planet involves far more than locating a world in the Goldilocks zone where liquid water can exist. For complex life to emerge and survive for billions of years, countless factors must work together in perfect harmony. It requires something like a cosmic perfect storm. Everything begins with the right kind of star. We needed a star like ours. The right size, old enough, burning steadily for billions of years. Most stars in the universe are either too large and short-lived or too small and unstable red dwarfs. Even if we had the right kind of star, we still needed to orbit at the correct distance, close enough for liquid water to exist, yet far enough to avoid atmospheric stripping or becoming tidally locked. But this was only the beginning. We needed a moon. Without our moon, Earth's axial tilt would have wobbled wildly over thousands of years, making the evolution of complex life nearly impossible. The structure of our solar system also mattered deeply. We needed a cosmic broom like Jupiter. Without it, our planet would have been constantly bombarded by catastrophic impacts. The planet itself had to possess the right properties as well. We needed plate tectonics to recycle the atmosphere and regulate climate over geological timescales, the right kind of magnetic field to shield us from harmful radiation, the correct atmospheric composition, and the right amount of water. Over billions of years, thousands of factors had to align in precisely the right way. If even one of these factors had been missing, Earth could have become a barren wasteland like Mars, or a scorching hell like Venus. According to the rare Earth hypothesis, the simultaneous fulfillment of so many conditions is extraordinarily rare in the galaxy. Billions of factors coming together to create a stage capable of supporting complex life like Earth is only the first act of the story. Even after this perfect stage was set, there was no guarantee that the play performed upon it, life itself, would ever reach intelligence and consciousness. What is truly astonishing is that we survived countless ordeals over billions of years, each one a major filter in its own right. Life on Earth faced multiple mass extinctions. The Permian-Triassic extinction, around 252 million years ago, wiped out 96% of marine species and 70% of terrestrial vertebrates. More recently, 66 million years ago, a massive asteroid ended the reign of the dinosaurs. Yet these catastrophes also opened space for new forms of life. Without the asteroid that eliminated the dinosaurs, mammals would have remained in the shadows, and the evolution of intelligent primates would not have been possible. The existence of complex life depended not only on stability, but on the right kind of instability at the right time. And even after surviving all these extinction events, the emergence of intelligence may have been the rarest event of all. Over billions of years, millions of species arose in countless forms, many of them extraordinarily successful. Yet none developed an intelligence that pondered the nature of the universe, wrote mathematics, or sent machines toward the stars. Intelligence is not the final goal of evolution. It is extremely costly in terms of energy, and if a species can survive through simpler means, there is no reason for the universe to make it smarter. The conditions that gave rise to human intelligence were the product of a highly specific combination of environmental pressures, social dynamics, and climatic changes. Those unique circumstances that forced our ancestors to leave the trees, use tools, and cooperate in complex social groups may never have come together in the same way on any other world in the galaxy. If this is true, then the silence we observe is not mysterious at all. It is exactly what we should expect from a universe where complex life is incredibly rare, and intelligent life even rarer. We are alone because the probability of it being otherwise is astronomically small. This possibility is both humbling and empowering. It suggests that we are not merely another species on another planet, but something genuinely unique and precious. We may be the only known attempt at consciousness in the universe, the only path by which the cosmos comes to understand itself, the only known source of art, music, love, and curiosity. This grants our existence a cosmic significance. And if the rare Earth hypothesis is correct, if we are singular beings born from billions of years of cosmic coincidences and nearly impossible probabilities, then this does more than resolve the Fermi Paradox. It places upon our shoulders a responsibility almost impossible to comprehend. Most stars in the universe are either too large and short-lived, or too small and unstable red dwarfs. Even if we had the right kind of star, we still needed to orbit at the correct distance, close enough for liquid water to exist, yet far enough to avoid atmospheric stripping or becoming tidally locked. But this was only the beginning. We needed a moon. Without our moon, Earth's axial tilt would have wobbled wildly over thousands of years, making the evolution of complex life nearly impossible. The structure of our solar system also mattered deeply. We needed a cosmic broom like Jupiter. Without it, our planet would have been constantly bombarded by catastrophic impacts. The planet itself had to possess the right properties as well. We needed plate tectonics to recycle the atmosphere and regulate climate over geological timescales, the right kind of magnetic field to shield us from harmful radiation, the correct atmospheric composition, and the right amount of water. Over billions of years, thousands of factors had to align in precisely the right way. If even one of these factors had been missing, Earth could have become a barren wasteland like Mars, or a scorching hell like Venus. According to the rare Earth hypothesis, the simultaneous fulfillment of so many conditions is extraordinarily rare in the galaxy. Billions of factors coming together to create a stage capable of supporting complex life like Earth is only the first act of the story. Even after this perfect stage was set, there was no guarantee that the play performed upon it, life itself, would ever reach intelligence and consciousness. What is truly astonishing is that we survived countless ordeals over billions of years, each one a major filter in its own right. Life on Earth faced multiple mass extinctions. The Permian-Triassic extinction around 252 million years ago wiped out 96% of marine species and 70% of terrestrial vertebrates. More recently, 66 million years ago, a massive asteroid ended the reign of the dinosaurs. Yet these catastrophes also opened space for new forms of life. Without the asteroid that eliminated the dinosaurs, mammals would have remained in the shadows, and the evolution of intelligent primates would not have been possible. The existence of complex life depended not only on stability, but on the right kind of instability at the right time. And even after surviving all these extinction events, the emergence of intelligence may have been the rarest event of all. Over billions of years, millions of species arose in countless forms, many of them extraordinarily successful. Yet none developed an intelligence that pondered the nature of the universe, wrote mathematics, or sent machines toward the stars. Intelligence is not the final goal of evolution. It is extremely costly in terms of energy, and if a species can survive through simpler means, there is no reason for the universe to make it smarter. The conditions that gave rise to human intelligence were the product of a highly specific combination of environmental pressures, social dynamics, and climatic changes. Those unique circumstances that forced our ancestors to leave the trees, use tools, and cooperate in complex social groups may never have come together in the same way on any other world in the galaxy. If this is true, then the silence we observe is not mysterious at all. It is exactly what we should expect from a universe where complex life is incredibly rare, and intelligent life even rarer. We are alone because the probability of it being otherwise is astronomically small. This possibility is both humbling and empowering. It suggests that we are not merely another species on another planet, but something genuinely unique and precious. We may be the only known attempt at consciousness in the universe, the only path by which the cosmos comes to understand itself, the only known source of art, music, love, and curiosity. This grants our existence a cosmic significance. And if the rare Earth hypothesis is correct, if we are singular beings, born from billions of years of cosmic coincidences and nearly impossible probabilities, then this does more than resolve the Fermi Paradox. It places upon our shoulders a responsibility almost impossible to comprehend. We are no longer ordinary inhabitants of the universe. We may have become the only known guardians of consciousness, curiosity, and the search for meaning. This represents a responsibility not only for the survival of our own species, but for the continuity of consciousness and intelligence in the universe itself. When we face challenges such as climate change, nuclear weapons, or environmental destruction, we must solve them not only for ourselves, but to ensure that the only known spark of consciousness in the universe is not extinguished. If we fail, it will not be just one species that disappears. Perhaps a galaxy or even the entire universe will lose its only chance to understand itself, to appreciate its beauty, or to unravel its mysteries. This does not mean we should expect help or guidance from advanced extraterrestrial civilizations. We must solve the challenges we face on our own. There is no galactic community waiting to welcome us. There is no ancient wisdom waiting to guide us. If we fail, we may not get a second chance. This places an immense burden on our shoulders, but it also reveals how capable we might truly be. If we are here despite impossible odds, if we have survived and progressed despite countless challenges, then perhaps we already possess the resilience and intelligence required to overcome what lies ahead. The rare Earth hypothesis does not necessarily mean we will be alone forever. If we survive and spread to the stars, we may eventually encounter other rare intelligences scattered across the galaxy or the universe. Such meetings would be unimaginably precious encounters between cosmic siblings who overcame impossible odds simply to exist. They would be the first conversations between minds that blossomed in distant corners of the universe after billions of years of solitude. Or perhaps our expansion itself will seed the galaxy with intelligence or life. Perhaps the universe is waiting for us to become gardeners, to carry the spark of consciousness from star to star, to ensure the continuation of life or intelligence, even if its natural emergence is extraordinarily rare. This gives humanity a cosmic purpose, to be the carriers of life and consciousness in a lonely universe. Whether we are truly rare, or simply the first to arise in this region of the galaxy, this possibility reminds us that existence itself is a miracle. The silence we observe may not be empty at all. On the contrary, it may be filled with potential, waiting for us to fill it with our voices, our discoveries, and our dreams. In a universe where intelligence may be extraordinarily rare, every conscious moment becomes valuable. Every discovery becomes significant. Every act of creativity or compassion becomes a cosmic gift. If we are alone, then we are also irreplaceable. And that makes our story not lonely, but magnificent. This is one of the deepest lessons of the Fermi Paradox. Perhaps the answer lies not in what we find out there, but in understanding who we are here. The silence is not an ending. It is a blank page offered to us, waiting for us to write our own story. And the next chapter of that story depends on how we choose to write it. When we step back for a moment and look at all the possibilities and hypotheses we have explored, one thing becomes clear. Whether we are alone or surrounded by hidden civilizations, we carry an extraordinary responsibility. Perhaps we are the only known experiment of consciousness in the universe. Or perhaps we are a single, quiet voice within a vast chorus we have not yet learned to hear. In either case, what we do matters on a scale far greater than we can easily imagine. Let us consider this for a moment. If the rare Earth hypothesis is correct, and intelligence truly is extraordinarily rare, then we are not merely another species on another planet. We are the universe's way of understanding itself, its only known source of art, music, love, laughter, curiosity, and wonder. Every human who has ever lived, every thought ever conceived, every discovery ever made, represents something utterly unprecedented in the cosmos. This is a staggering responsibility. The choices we make about the future, the decisions we make about how we treat our planet and one another, have consequences that extend far beyond our immediate concerns. If we destroy ourselves through war, environmental damage, or simple carelessness, we may be extinguishing the only conscious light in an otherwise dark universe. But even if we are not alone, even if the galaxy is filled with hidden intelligences watching us, we still carry a unique burden. We are the only human civilization that will ever exist, the only species that will see the universe through human eyes, marvel at it with a human heart, and reach for the stars with human dreams and determination. Our perspective is irreplaceable. Even if 1,000 other species have gazed at the night sky and felt the pull of cosmic mystery, none have felt it exactly as we do. None have expressed it through human language, human art, or human science. None have brought to the universe our particular combination of curiosity, creativity, and stubborn hope. This uniqueness extends to our potential as well. If we survive or spread to the stars, we will not merely be adding another voice to the galactic conversation. We will be adding a distinctly human voice, carrying all its unique insights, perspectives, and ways of understanding existence. We will be bringing something genuinely new to the cosmic community, something that has never existed before and may never exist again. Perhaps this responsibility is exactly what we need. Perhaps the awareness that we can be unique and that our existence may matter on a cosmic scale is what will help us overcome the challenges ahead. Perhaps understanding our potential cosmic significance will inspire us to be better than we sometimes are, to think more carefully about our choices, and to work more cooperatively for our shared future. Every human achievement, from the first stone tools to the latest space missions, represents part of the universe's attempt to understand itself. Every work of art, every scientific discovery, every moment of love and compassion adds something valuable to the cosmic story. Whether we are alone or not, whether we are observed or ignored, whether we are destined for greatness or for extinction, we have the opportunity to be part of something extraordinary. We have the chance to be worthy representatives of consciousness itself in this universe. We are conscious beings living on a small world, orbiting an ordinary star. We are advanced enough to reflect on our place in the cosmos, and wise enough to realize that we do not understand it nearly as well as we once thought. The question, "Where is everyone?" carries within it many assumptions about intelligence, communication, technology, and the nature of existence itself. Perhaps the true answer lies in directions we have not yet thought to look. Perhaps the universe is stranger than we can imagine. Perhaps consciousness takes forms we would not recognize, exists on scales we have not considered, or operates according to principles we have yet to discover. Perhaps the fundamental constants of existence, such as the speed of light or the arrow of time, are more flexible than we assume. This opens the door to forms of communication or travel that currently seem impossible. Perhaps the galaxy is filled with intelligence, but that intelligence may be so alien to our way of thinking that we simply do not recognize it as intelligence at all. The beauty of not knowing is that it keeps all possibilities open. As long as the universe appears silent, we can imagine it filled with hidden wonders, hidden civilizations, and forms of life and intelligence that could surprise or delight us. Silence preserves mystery. It sustains the feeling that anything may be possible, just beyond the limits of our current understanding. Perhaps that is the secret. Perhaps the universe is arranged so that whenever we believe we are beginning to find definitive answers, it presents us with new questions instead. Perhaps the Fermi Paradox is just one note in a vast symphony of cosmic mysteries designed to keep us curious and humble for as long as we exist. There is something deeply human in how we respond to this mystery. We do not simply accept the silence. We tell stories about it. We fill the empty spaces with possibilities because we cannot bear to think of them as truly empty. We resist accepting that we might be alone because loneliness, even cosmic loneliness, runs counter to something fundamental in our nature: the impulse to imagine, speculate, and dream about possibilities beyond our current knowledge is one of the most beautiful aspects of human consciousness. We are not content merely to exist. We must find meaning in the patterns we observe. We must understand, and we must connect. These patterns drive us to keep searching for signs that we are not alone, even when they seem to suggest that we are. Perhaps this curiosity itself is the answer to the Fermi Paradox. Perhaps the universe is silent not because it is empty, but because it is waiting for us to develop the right questions, the right tools, and the right perspectives to join the ongoing conversation around us. Perhaps contact is not about them finding us or us finding them. Perhaps it is about becoming the kind of beings capable of participating in a cosmic community that already exists. The search for intelligence beyond our world changes us. It forces us to reconsider what intelligence truly means, what life truly requires, and what consciousness truly represents. It compels us to examine our assumptions about the nature of existence and to remain open to possibilities we have not yet imagined. Every time we lift our eyes to the sky, every time we wonder about life among the stars, we are doing something extraordinary. We are taking part in the universe's effort to understand itself through our own minds. At the end of this long journey through cosmic silence, perhaps the most important destination is ourselves. The Fermi Paradox, with its questions about the universe, is really a mirror reflecting our deepest human curiosity. Whether we are alone or surrounded by unseen observers, the ultimate answer matters less than the fact that someone is here to ask it. And just this presence, human, conscious, curious, is remarkable, even miraculous. Consider the chain of events that had to unfold for this moment. Stars were born and died to create the atoms that make up our bodies. Our planet formed and became suitable for life. Simple chemistry crossed a delicate threshold, and over billions of years, life grew more complex. Eventually, intelligence emerged. Consciousness followed. After countless improbable steps, beings capable of reflecting on the universe appeared. We are not separate from the universe. We are the universe awake, aware of itself. Through our eyes, the cosmos witnesses its own beauty. Through our minds, it questions its deepest secrets. This perspective changes how we understand the great silence we observe. If consciousness is rare, if intelligence is precious, then every question we ask, every spark of curiosity, becomes infinitely valuable. Perhaps the more important fact than where is everyone is that someone is here to ask it. Now, let these thoughts calm your mind. All the worries that occupied your day are small against this vast cosmic backdrop. With each breath, feel yourself as part of this immense and serene silence. This is not emptiness. It is a calm filled with potential, holding all possibilities and unanswered questions. Let your consciousness rest in harmony with the deep, tranquil rhythm of the universe. Thank you for sharing in this human journey of cosmic curiosity. Good night.